Welcome back to Think Thrice Problem Solving. Today we're going to be going through a common problem, but just looking at a fun solution for the derivative of arctan. So most people memorize the derivative of arctan, and some don't know exactly where it comes from. So we're going to go through the solution here right now. If you want to try this on your own, please pause the video and go through it. Otherwise, let's go ahead and work through the solution. So what we're going to do is we're going to set we're going to set theta equal to arctan of x. And what does that mean? That means that the tangent of theta is equal to x. So we're trying to find the derivative with respect to x, so let's use implicit differentiation, and let's take the derivative with respect to x of both sides of our equation. What does that give us? That gives us secant squared of theta times d theta dx is equal to the derivative of x with respect to x, which is just 1. And we can solve this, and we can see that d theta dx is equal to 1 over secant squared of theta, which is just equal to cosine squared of theta. All right, so I have the derivative with respect to x of cosine squared of theta. And we can do a quick substitution. So remember how we originally defined theta. So we know that d theta dx is actually equal to cosine squared of the arctangent of x. So this is a solution, but it's not very satisfying. So let's try to get this in the normal format that we see it. So let's look at this triangle that we're taking these trigonometric functions of. So let's go ahead and draw that. There's some angle theta. And we know that arctangent tangent of theta is equal to x. So if tangent of theta is equal to x, that means that if I have a y component that's equal to x and an x component that's equal to 1, tangent of theta would give me that number. So that's going to be a similar triangle to this triangle. And then that would give me a side over here of the square root of 1 plus x squared, just using the Pythagorean theorem. So that gives me a little bit of a relation between theta and the sides of my triangle. So if I took cosine of theta now, I know that cosine of theta is going to be equal to 1 over the square root of 1 plus x squared, because I just have adjacent over hypotenuse. And this is where this all comes from. So now I get d theta dx is equal to cosine squared of theta. So cosine squared of theta, which is equal to 1 over the square root of 1 plus x squared squared. Oops, sorry, and this should be d theta dx. And what we'll finally get here is d theta dx is equal to 1 over 1 plus x squared. And this is the derivative that we're all so familiar with that we memorized from our books. And that's how we come to that solution. So thank you for working through this problem with me. If you enjoyed it, please like and subscribe. If you have your own problem that you'd like me to solve, please submit it. And as you're working through problems of your own, always remember to think thrice.